Okay, fifth numerical. So two forces, each of magnitude 10 Newton. So two forces of equal magnitude. One is of 10 Newton, the other one is also of 10 Newton. One is vertically upwards, other one is downwards. Okay, so there are two equal and opposite forces. Okay, and then it's been applied on a rod, okay, uniform rod. And the length of this rod is 4 meter. Okay, so this entire length is 4 meter. It is pivoted at point O, and there are two forces that are acting in opposite direction. So what has been given to us? First, force of magnitude 10 Newton each in opposite direction, and the second is the entire length of the rod, that is 4 meters. Now, what they have asked us to determine the magnitude of resultant moment of force about point O. So what is the moment of force, resultant moment of force, that is because of these two forces, what is the moment of force that has been generated at point O? So torque would be how much? Okay. Now according to moment of couple, either force into perpendicular distance between the force or the couple arm. So the torque or the moment of couple is either force you multiply with the total distance between the two forces. So one force is applied at point A, the other force at point B. So total distance is 4 meters, and any force, since both the forces are equal, okay, both are 10 Newton, we can take any one force. So moment of couple or torque would be either force, that would be 10 Newton multiplied by perpendicular distance between the two forces, that is 4 meter. So the answer would be 40 Newton meter. Okay. Important point is that you need to mention that this formula, that is according to the moment of couple, either force into perpendicular distance between the two forces. Okay. Alright, this is an interesting numerical over here. So figure 1.31 shows two forces each of magnitude 10 newtons. So that two forces, one 10 Newton in this direction, the other one in this direction, acting at point A and B, and the separation between them is 50 centimeters in opposite direction. They are moving in opposite direction. Calculate the resultant moment of force of two forces about point 1, that is at point A, at point B, and at point O. So O, we know that it is very similar to the previous sum where we found the total moment of force when two equal and opposite forces have been applied exactly at the middle of the two forces. So at O, we know we can use the moment of couple, okay, and we can find out. But what about point A and point B? Now they have said calculate the resultant moment of two forces, and it means both the forces at point A. So what is the impact of force, that is this force that has been applied 10 Newton at point A, and force B that has been applied at point B. Okay, their impact on this point A. So first let us understand this. If I apply a force, say this is the axis on which this globe is rotating. Okay. If I apply a force, say over here in this direction, such that exactly in the center over here in this direction, if I apply a force, this globe will fall down, okay, because the force will pass through this axis and it will make the globe fall down. It will not rotate. Either I have to move little on the left inside or on outside over here. I have to apply force over here so that it can move. Right at the center, if I apply the force, the globe will not move, instead it will fall down. The other example, a better one, would be this, a wheel. For example, this wheel, okay, if I apply a force, say at this point, it will move in a clockwise direction. If I apply a force in this, it will move in an anti-clockwise. What will happen if I apply a force over here in this direction? If it is passing through the axis, okay, the torque generated would be 0. There won't be any torque that will be generated over here because there is no perpendicular distance. This was the line of action. Okay, this is the perpendicular distance. Oops, this is white. No. Okay, so this is the line of action of force and this is the perpendicular distance. Hence, there was torque generated. Here also, this is the line of action of force and this is the perpendicular distance. Hence, torque was generated. Here, the angle torque is not generated because it is passing through that point. Hence, it will be, torque would be 0 over here. Alright. So, based on this information, we'll solve this numerical. Okay. So for force that has been applied at point A, okay. So first thing, what has been given to us at point A. So for first one at point A, we'll be finding out force because of this. This would be the torque because of this would be 0. Okay, because it is passing through the point A. Okay, this force is passing through point A, hence the torque would be 0. And we have to calculate for two forces, that is for second force, that is this B. Okay, so B is also passing, so B will generate a torque on A, so this distance, okay, the distance between them, okay, and the force. So torque because of B, so torque because of A will be 0 and because of B would be force into perpendicular distance. Force is how much? 10 Newton into perpendicular distance is how much? 50 centimeters. Now remember one thing, distance we have to convert it into meters. So we know 50 centimeters, you'll divide it by 100 to get in meters. 0, 0 cancel. This 0 will jump over here. It will give us 0.5 meters. So we'll multiply this with 0.5. So 10 Newton into 0.5 meter. Okay. So first just multiply this. Forget about this point decimal. 5 tens are 50. Okay. After that 50 you put a decimal, that means 5 Newton meters. Alright. Now this force will be in which direction? Of both the forces, this force and this, they'll generate a torque in a clockwise direction. So this will be in a clockwise direction. Since only one force is acting, this is the downward force, this will generate a clockwise moment. Okay. Now second, similarly for point B, torque due to force at B will be 0. Similarly, now we are considering point B. Now this line of force is passing through this point B. So because of this force, there won't be any torque generated. It will be 0. Okay. Now because of torque A, that is because of force that is at point A, this will be force into displacement, force into distance. This will give us, oops, force is how much? Again 10 Newton. Now this time this force it is, okay, this force, okay, because we are considering a point B. So this force will generate some torque. So this force and the distance between them. So distance between them is 50. This is 50 centimeters. So again we won't convert it, 0.5 meters. So this will again give us 5 Newton meter. Okay. A third part of it is you can use, oops, third part you can again use according to, where should I write? According to moment of force, okay, moment of couple. Okay, so third, torque at point O. So torque at O will be, okay, either force, that is 10 Newton, any one force, into distance between those two forces. Okay, that is again 50 centimeter. That will give you 0.5 meter. It will be again 5 Newton meter. Now you can use this. So if you're using the couple formula, you have to mention it. Okay, moment of couple of couple is equal to either force into couple arm. Okay, and you can solve this, or you can do in a linear method. Second method would be to find torque at O. We have to first find torque that is generated by A, that is torque at A plus torque at B. So torque at A would be how much? A torque, you know what formula is? Force into distance. So force is how much over here? Force is 10 Newton into distance is how much? Now this distance is half of this. So this will be 25. That will be 2. Okay, I'm so sorry. This will be 25. So it will be 0.25. Okay, because you will divide this 25 by 100, it will give you 0.25. So 10 into 0.25, it will give you 2.5 Newton meter. Plus again torque at B because of B. So B again it is force into distance. Force is for B it is 10 Newton into distance would be how much? This distance. This is again half of it, 50, that will be 25. So 25 upon 100, it will give you, say 25 upon 100, 0, 0 here also you can cancel. This will become 2.5. So this will be 2.5 Newton meter. Then you'll add both of it, 2.5 plus 2.5, it will give you 5.0 or just 5 Newton meter. So torque O will be 5 Newton meter. You can do it either by this method or by this method. Okay. Alright, I hope you understood this. Alright, we'll finish the last one quickly. Okay, a steering wheel of diameter 0.5. So suppose there is a steering wheel we have. Okay, the diameter of it is, so this distance is 0.5 meters. Okay, and the magnitude of force is 5 Newton. The two forces, okay, are applied such that it rotated in anti-clockwise. So in order to move it anti-clockwise, the forces should be this way. One would be in this way, the other one would be in this direction. Okay, so it will move in an anti-clockwise direction, or you can apply force this direction and then this direction, any which ways, because you have to draw it. So you can draw it this direction and this direction also. It will generate an anti-clockwise movement. So steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces of magnitude 5 Newton. Okay, so each of magnitude 5 Newton. Draw a diagram to show the application of force and calculate the moment of force. So what is the torque that has been generated? Now again, for us, force is given as 5 Newton and the distance between two forces, okay, that is the diameter. So distance between two forces is, so distance between two forces is 0.5 meter. Alright, now according to moment of couple, we have either force, that is any one of the force, so 5 Newton we can take, into perpendicular distance, okay, distance between two forces. So distance between these two forces is nothing but the diameter of it, and diameter is given to as 0.5 meters. So 0.5 meter. So this is 5 5s are 25. There's a point, so you put a point over here, Newton meter. Alright. Alright, thank you so much. Bye.